This is AQA Level 2 Further Maths, exam question set 7 for the non-calculator paper. We've got 3 questions. First question says that work out the exact value of x given the diagram shown. This triangle is a right angle triangle because this angle here is a right angle. And that means I can use Pythagoras theorem to find x. According to Pythagoras theorem, x squared plus 9 over 10 squared must be equal to 1.5 squared. I'll change 1.5 to an improper fraction. So that will be 1.5 is equal to 3 over 2. So it means this is equal to 3 over 2. I can now go ahead and use Pythagoras theorem as stated before, and that will be x squared plus 9 over 10, all of that squared, must be equal to 3 over 2 squared. So that means x squared plus 81 over 100 is equal to 9 over 4, because 9 squared is equal to 81, 10 squared is equal to 100, and 3 squared is equal to 9, and 2 squared is equal to 4. I can now rearrange to get x squared is equal to 9 over 4 minus 81 over 100. So x squared is equal to, I will find the LCM of 4 and 100. And the LCM of 4 and 100 is 100. So I can draw a line here and then put my LCM here. And then 4 goes into 100 25 times. So I'll multiply 25 by 9. And if I do that, I'll get 25 times 9, and that will be 9 times 5 will give me 45. So that will be 5, remainder 4, and then 9 times 2 will be 18, and 18 plus 4 will be 22. So I'll have 225 here minus, and then 100 goes into 100 once. So the 1 times the 81 will give me 81. So I have 225 minus 81. So now 225 minus 81 will give 4 here, and then 22 minus 8 will be equal to 14. And so this numerator is 144. And so the equation becomes x squared is equal to 144 divided by 100. Now I'm looking for the value of x. So I will find the square root of both sides of this equation here. If I do that, I'm going to get x on the left hand side, and then the right hand side becomes square root of 144 over 100. Because I'm looking for a length x, which cannot be negative, we take the positive value of this square root here. And that means x is equal to the square root of 144 is 12 over the square root of 100, which is 10. I can reduce that to get 6 over 5, and then rewriting this as a mixed fraction, x will be equal to 1 minus 1 over 5. And that is the value of x required. Question 2. The diagram shows a prism, this one here, and a cone, which is this. All measurements are in centimeters. The cone has a base radius of r and a height of h. So this is the base radius and a height h. The prism has a triangular cross section, and this is a triangular cross section over here. So the prism has a triangular cross section with a base of x and a perpendicular height of x as well. The length of the prism is h, and so this is the length of the prism. The volume of the cone is 4 times the volume of the prism. Express r in terms of x. So we start by finding the volume of the cone and of the prism. So the cross-sectional area of the prism, which is this, is a triangle, and the area of a triangle is given by half the base times the height. So we can say the cross-sectional area of prism is equals to half times x, which will simplify to half x squared. We can use that to find the volume of the whole prism. So I'll multiply this cross-sectional area by h. And so I'll have volume of prism is equals to half x squared, the cross-sectional area, times the height. And that will reduce to half x squared h. For the volume of the cone, is equals to 1/3 times the area of the base, which is in this case is a circle over here, times the perpendicular height, which is h. Now the area of a circle is pi r squared, and so we have 1/3 times pi r squared, which is the area of the circle, times the height. Simplifying this will give 1/3 pi r squared h. But the question says that the volume of the cone is 4 times the volume of the prism. And so this volume here, which is that of the cone, is equal to 4 times the volume of the prism, which is this one here. And so 1/3 pi r squared h is equals to 4 times half x squared h. At this point, I can divide both sides of the equation by h. If I do that, I'm going to get this h cancel with this h, and then 2 goes here 1, and 2 goes here 2. So I'll be left with 1/3 pi r squared is equals to 2x squared. I can now rearrange this step by step. I'm going to get pi r squared equals to 3 times 2x squared. And so pi r squared is equals to 6x squared. Then I'll divide both sides of the equation by pi. So I have r squared is equals to 6x squared divided by pi. So I'll find the square root of both sides of this equation here, and that will give me r on the left hand side equals to the square root of 6x squared over pi. I can simplify that by saying r is equals to x times the square root of 6 over pi, because the square root of x squared is x over here. And that is the required expression for r in terms of x. Question 3. Solve the following equation. 1/8 to the power x is equal to 30 divided by 2 to the power 56 minus 4 to the power 26. I'll start by rewriting 8 to the power x as a power of 2 and 4 to the power 26 as a power of 2. And so 8 to the power x is the same as 2 to the power 3, which is 8, all of that to the power x. And the laws of indices says that when you have a to the power n, all of that raised to the power m, this is equivalent to a to the power mn. So that means that 8 to the power x will be equals to 2 to the power 3x. 4 to the power 26 is equals to 2 to the power 2, which is the 4 over here, and all of that raised to the power 26. And using the same rule here, I can write this as 2 to the power 52, because 2 times 26 equals to 52. So I'm going to go back to the equation and rewrite it as follows. 1 over 2 to the power 3x is equal to 30, can be written as 2 times 15. And so I have 2 times 15, all of that over 2 to the power 56 minus 2 to the power 52, because we got that one over here. Then I'll do a further simplification by saying 1 over 2 to the power 3x is equals to 2 times 15 over 2 to the power 52 bracket 2 to the power 4 minus 1. So I've just factorized the denominator right here. 2 to the power 52 is common, so I can bring that one out of the brackets over here. And when I do that, I'm left with 2 to the power 4 for this part, and then 1 for this part here. Because I'm using the laws of indices again, which says that a to the power n times a to the power m is equals to a to the power m plus n. And so 52 plus 4 is equals to 56. Now, having done that, I can go ahead and do a further simplification by doing this. 1 over 2 to the power 3x is equals to 2 times 15 over 2 to the power 52 times 15, because 2 to the power 4 is 16 and 16 minus 1 is 15. So I can now simplify this fraction by cancelling down as follows. 15 goes to 1 and 15 goes to 1. So I'm left with 1 over 2 to the power 3x is equals to 2 over 2 to the power 52. So 1 over 2 to the power 3x is equal to 2 over 2 to the power 51 times 2, because this is 2 to the power 1, and 1 plus 51 is 52. I've done that because I can now reduce this fraction as follows. 2 goes to 1 and 2 goes to 1. So now I can have 1 over 2 to the power 3x equals to 1 over 2 to the power 51. Now I'm going to find the reciprocal of both sides of this equation here. If I do that, I'm going to get 2 to the power 3x over 1 is equals to 2 to the power 51 over 1, which simplifies to 2 to the power 3x equals to 2 to the power 51. According to the laws of indices, the base of the left-hand side of the equation is equal to the base of the right-hand side of the equation. And so that means that the powers must be equal. And that means I can equate 3x to 51. That means x is equal to 51 divided by 3, and therefore x is equal to 17. And that is the required value for x. And this brings us to the end of this session on exam question set 7 for AQA Level 2 Further Maths. Thank you for watching. See you in the next video.